That caught me unawares, and I think the microphone was unmuted too. I've just been rushing around trying to get things organized for the the live stream, and I don't have the scene switcher set up or anything. Anyway, we're here now. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Now, before we get into the other stuff, just a very quick comment about the acknowledgement of traditional owners, because I'm sure that there are many people that would prefer me to not do it and think, he'll forget about it eventually and then we can just do the tech stuff and not worry about that. But that is actually part of the reason that I do it, is to keep reminding myself. There are really a couple of reasons. One is that as a white guy sitting here in 21st century Australia, it is very easy to simply forget about both the historical and current situation and things that are faced by Aboriginal Australians. So doing that acknowledgement each week is just a way of keeping it in my mind so I don't forget about it. And secondly, because Aboriginal people don't get to forget about it. So as a white guy, I will do a little bit of the labour and pitch in. So where is everything? I don't know. Okay, we've got a heap of people in the chat this morning, all hoping for smoke and explosions and a train wreck with the live PNP stuff. Yes, Peter, you're absolutely right. Sovereignty has never been ceded. And it is very uncomfortable to acknowledge that for many people, and that is why I acknowledge it. The discomfort helps us grow. Okay, so as I said, I'm in a mess this morning. I was rushing around because when doing a PNP job, particularly for a new board that hasn't been done before, there is a whole lot of setup that goes into it, and it's kind of fiddly and boring. And so I was trying to get things done before I started the live stream, and I've got a you don't want a train wreck, just think it's going to happen. Yeah, I think it's going to happen, but that's fine. That's entertaining. So it's not very fun for you to watch me try to fiddle around with getting the jig in place to hold the PCB in the right position and taping the stencil onto the frame and all of that sort of thing. So I was doing that sort of thing before the live stream so that we could get on to we could get on to placing some components. So first though, okay, this is going to be a bit of an assembly stream today because we've got two boards. Technically we have four boards to assemble. One of them is the UT61e multimeter Wi-Fi board that we've been designing on the stream for, it seems like 1,000 years now. And the other are the three different versions of the light switch controller breakout. The portion of it with the RJ45 connectors and the I2C interface, so that we can address light switches. And I've done versions of that, new versions of that, so this is version 3.0 of the board, with 8, 16 and 24 ports. And as a test, yesterday I assembled the 8-port version, and let's just see if, actually what I'm going to do, I'm going to be switching cameras constantly today, so I am just going to get Touch Portal up and running and get this Samsung tablet logged in. Oh, it's not even booted. Alright, I'll get the tablet started and then I'll be able to switch. So let's try overhead camera, that one. Okay, so this is the, it's not quite in focus. Why is that? Should be on autofocus. So that is the 8-port version of the breakout, and you can see it doesn't have the big RJ45 socket on it. It doesn't have the I2C headers or the pin headers for the addresses yet. So all I did was run the pick and place job, and I manually put on the chips and the capacitor because I don't have those loaded in the pick and place machine. But the resistor networks that you can see here, these were all done in the pick and place machine, and LEDs and things. In fact, let's see if the microscope is working. Microscope view. Does this work? Oh, it's working. It's just not focused. All right, let's take some zoom out and get some focus happening. Which way? That way. Looks like it's focused. So there you can see some of the resistor networks and more of them going across the board. So yeah, these were all placed on the pick and place machine. But I hadn't actually run these resistor networks on the machine until yesterday. And so I just set the feeders up and got things working. So it's all a little bit of an unknown, which makes it more entertaining. Come on, why is this tablet not starting up? Ah, maybe it's booting up now. All right, so what was I getting at? That's right. So what we've got is a 16 port version of this board that we're going to assemble today, but we're also going to assemble this. I haven't even opened these. These are the PCBs for the multimeter interface. Let's switch back to overhead. There we go. They got the little squirrel on them, and it's all still sealed in its packet. Because there are only a couple of parts on this one, here we go. Because there are only a couple of parts on this one, and also I didn't get it panelized, obviously. These are just loose boards. I'm just going to use the syringe, put some solder paste on this. I'm not even going to bother running it through the oven. I'm just going to hit it with hot air, I think. Maybe. We'll see. And we'll see how it goes. So, what do I need? Okay. Oh look, my tablet has finished booting. That is going to be very helpful because I am going to need to be switching cameras constantly. And once we get to the pick and place, I'm going to have to switch to using my phone as the camera. Here we go. Touch portal, starting. Oh, actually, while this is starting, this is, yeah, just a little update on the whole GoFundMe thing. So, as I mentioned last time, my goal was $4,000, which is enough to buy either, hopefully, because we don't even know the prices yet, but when Apple comes out with its new, let's see, yes, the camera switched. When Apple comes out with its new devices, hopefully it'll be enough to get either a 16-inch MacBook Pro or one of the up-spec'd Mac Minis and an ultra-wide display. That's my goal, one of those two things. So my commitment basically is that any contributions that go above that goal will be spent on things that help the channel in some way. It's not just going into my coffee fund or anything like that. So I have already ordered two things. One is I've ordered an ATEM Mini Pro video switcher, and I've had a couple of people recommend this to me, and so Dave Jones has been using one recently, and he told me I should get one basically. He said, get this, it'll help. And so I've ordered one of those. It hasn't arrived yet. It'll probably arrive on Monday. It's in transit right now. And that will allow me to take cameras in and then do all of the video switching and picture-in-picture and all of those sorts of things in an external hardware device. So it puts no load on my computer at all. And in fact, it's got Ethernet built in, which means I can connect it to my network. It can log into YouTube, so I could do the live stream entirely from the video switcher without using my computer, which might help a lot, because running OBS and doing these streams seems to put a big load on it, which then makes everything else slow. So I think that will be a big improvement. And the other thing that I've ordered is a Rode Go 2 microphone system, which is a dual microphone system, which will help in other ways that I won't go into right now. Okay. Some Call It Fun says, I think the Explaining Computers guy uses ATEM2. Yeah, they seem to be very useful. So Sion said, you did, which one did you get? There are 3 models, right? Different internal storage and capabilities. I think there are 6 models. There are, yeah, this is kind of sidetracking, but it's interesting. There are versions, yeah, there are 6, maybe 5 models. So basically there are 3 different hardware models, and then for each of those hardware models there is a regular and an ISO version, but only for the top 2. So the base one is only like $400, and that's just a video switcher. The next one up, which is the one I got, which is the Pro version, has built-in client that connects to YouTube and does all that sort of thing. Then there's the ISO versions do isolated channel recording, so that what you can do is live stream and record all of your inputs onto separate output channels, and then you can mix them in post-production or whatever. And there is a huge version that does 8 inputs, and that comes in both regular and ISO. Anyway, this is kind of getting off the topic. Alright, so there was a question. Christian said, where were the PCBs ordered from? They were ordered from JLC PCB. So I'm not sponsored by JLC PCB. I'm just a customer. I've ordered thousands and thousands of PCBs from them, and they've provided me good service. So it is time, I think, to start pasting up a board. And I'm not going to pick and place this. This little one, I am simply going to, come on, microscope. Ooh, look, a squirrel. I even put it down in the right place. Hang on. I just realized that the side view, side camera, the view, let's see. I'm going to turn on another camera and see if it works. What happens if I turn that on? Nope, nothing happens. Sorry, I'm just messing around in OBS right now, trying to oh no, that's all right. Trying to get these cameras working. So, yeah, I need to reconfigure my whole camera setup. But look, a squirrel. I'm gonna, let me see. This is the, not the side, oh yeah, it is the side of the board where we need to put stuff on. It's a little bit bright for the camera. Let me turn that down, and then you'll be able to see it a little bit better. I'm also struggling to get the focus spot on for the camera. That looks pretty good. Now, time to squirt on a little bit of solder paste. I pulled this out of the fridge just a little while ago, so it's still a bit warm, but it seems to be flowing okay. I'm gonna have to look up the guide. Actually, I can probably figure it out. I've got to look up what the which one of these is which resistor. So the circuit is so simple that I can basically do it from memory, I think. But I'll try to avoid putting things into the wrong place. Now I'm going to need a it was an N MOSFET going on there, 2N7002, so I've got one of those lying on the bench. Oh, it's upside down. So I'll stick one of these in. It goes in there. And then what did we have? That would have a, I think it was a 10K pull down, is my guess. I'm going to open Eagle in a moment and have a look. That'll just be a decoupling cap for the LED, so it's not even critical. because what I was trying to fix earlier with the camera setup is that right now all you can see is the microscope. You can't see the room camera or anything, which means you can't see what I'm doing. I was going to show you, let's see, okay, put decoupling cap on there, and then I've got to find a WS2812B, which I have over here in the pick and place machine. So I'm just going to swipe one out of the feeder and stick that in. Which way? Orientation that way. Okay. And now, what am I doing? That's right, desktop. Let's go to the desktop and have a look in Eagle, because I just want to make sure that I'm putting the correct parts down on this board. I think it was a 10K pull down, and then there would be something else in series with the data line. What was that? I don't know. Probably a 1K. All right. What do we have? Projects. Wi-Fi. Yeah, doing this sort of thing. You know those cooking shows where... Okay, I have trouble talking about something while I'm doing it at the same time. So it's kind of like those cooking shows where they have two people working in a kitchen and they're competing against the clock and they're talking to each other. So they're saying, okay, now I'm putting the sugar in the bowl and now I'm mixing it. Oh, and then I'm going to open the milk. And they're basically just commentating every single thing they do while they're frantically doing it at high speed. I can't do that. So what have we got here? I should have just turned on the values layer. So yeah, 10K pull down, and what's this one over here? Another 10K. What's the go with that? That actually seems kind of strange. Where? Oh, okay, that's just because it was the pull up there, and then we got the bias on the gate. Okay, that makes sense. So I would have made the bias on the gate too strong. So what we need is just a couple of 10K resistors. And then back do. Oh, Sion says I do that. I hate that I do that. Oh, so you'd commentate while you're doing things? You just talk about it? Okay, so I need to get in the habit. I need to practice, not get in the habit. I need to practice. If you can do it, it's a good thing, as long as there's nobody else around. I do talk to myself while I'm working sometimes to like reinforce things in my head. Like if I'm, because my very short-term memory is not good. For example, I can't read a complete phone number and then 30 seconds later just recite the entire phone number. So if I see something like a phone number on the screen or somewhere and I've got to type it in somewhere else, I will go 0413 123 123. Like I'll read it in chunks because it's just a limitation of the way my brain works with my extreme short-term memory. I don't have enough slots for that, you know, to load a sequence into memory and hold it. So I've forgotten what I was talking about. So when I'm doing things like that, I say it as just a way of reinforcing and overcoming that limitation. So if I'm like caught, okay, here's a good example. You can't really see it very well. This is the notebook that I use for keeping notes in relation to pick and place machine. So when I'm sitting here on my own, no one else in the room, and I'm writing down something, like I was noting down X and Y coordinates of a board location, I will just say to myself, 93.9, 82.5. Like, I'll just say it out loud. Now, what I was doing was looking for resistors. That's right, so 0603 resistors. and I'll chuck a couple of these on the board. But what I don't do very well is things like, no, not overhead, I want microscope. Yeah, what I don't do very well, actually while I'm here, sorry, I'm going to go back into OBS. I am just going to fix this layout. What have I got? So I've got front camera, internal, front camera, HDMI front camera. Okay, I'm going to copy that and I'm going to stick it into this. Yes, there we go, it works. All right, so now you should be able to see both the room camera and the microscope. So, as I was saying, what I'm not good at is saying, all right, now I'm just going to look for some 10K resistors. All right, I've got a 10K, and now I'm moving the board into position just so that I can get the alignment correct, and I'm putting it down, and it's gone into this, into the solder paste. I need to get another 10K, so I'll put that out. Damn, it's upside down, so I've got to turn it over. All right, I've turned it over, got to rotate it to align it correctly, put it in position, put it down, it's in the solder paste. You know, just talking through things like that. I don't do that very well. I lose my train of thought when I'm trying. Okay, so we have some parts on the board. And apart from the connectors, that's basically it. This is all that is on this board. And what I'm going to do is, where is it? I have a chunk of wood that so this surface that the board is sitting on right now is, it's like a rubberized static dissipative surface. It's got a carbon impregnated back. If I turn it over, it's black. That's all the carbon impregnation. And then I've got this connected to an earth strap. So this is actually really durable. And I'm going to zoom that microscope out a little bit more. Oh, no, I'm not. I want to let you see the solder paste flow. So let's get some more light on it, if I can get that to stay on. Yeah, so what happens is if I use the heat gun directly on something that is sitting straight on it, the temperature makes it expand and it bubbles. So what I do is I've got this chunk of wood that I just have around the bench. I'll put that underneath and you can see it's got scorch marks on it from hitting it with the hot air. Okay, so I'll get that into about the right position. And then if you have a voice assistant, a she who shall not be named, you should probably hit that mute button right about now. I'll give you 5 seconds to do it. All right, if you're all ready, you've hit mute. I can say, Alexa, please turn on the soldering iron.
Okay.
Nice, thank you.
This might answer your question.
Alexa, stop. All right, now, I'm gonna have to try to watch this on the screen. In fact, let's get some more zoom happening, because it's really cool watching solder paste do its thing. Which way? No, I need to move it that way. I'm kind of looking sideways to try to see this on a screen that is some distance from me. And now I need to bring in a bit more light. All right, now let's see the miracle of solder paste. Bring in the hot air. Look, you can see that it's starting to get runny as it heats up. I think I might need to turn this airflow down a little bit. It's a bit high. That's already low. Okay, bring it in again. So the solder paste will start to heat up and go all runny, and then you'll see it suddenly turn silver as all the flux boils off, and then all the little balls that you can see, there they go. They turn from like grey goopy toothpaste into a silver solder, as you would expect. And you can see the surface tension pulling things into place. Now, doing Oh, look, it's just flashed over there and there. I'm going to turn this board around so I can get to the LED from the other side. And I don't want to overheat the LED. WS2812s can be quite finicky to bake. If they've been sitting around for a while, they can end up with moisture absorbed into, there it goes. I think it's reflowed now. It's a bit hard to tell from that angle. Yeah, they can end up with moisture absorbed into the coating that goes over the top. So this part right here, what they do is you can see there's the chip in the middle there, which is the LED with its bond wires. And I'll see if I can focus that a bit better. There we go. So you can see the LED element with its bond wires coming off it. You can just see the thin grey wires coming up and sort of to the left, and you can see one coming down here. Now what they do is that's all bonded, and then there is this goopy substance that is squirted into it, which then solidifies, and it can absorb moisture over time. So if the LED has been sitting around in an uncontrolled environment, like mine have been, now let's see if we can get a bit of an angle on this and do an inspection on that, because I'm not entirely convinced that this, oh yeah, looks like it did, I think. Yeah. And then I'll look through here because I get a better view. Yeah, it did. So what happens is that if moisture ends up in that, oh, you can see that I've melted the top edge of the case just there. When you heat it up, either in a reflow oven or with hot air, the moisture that is inside, that has been absorbed into it, heats up as well, obviously, and it can boil, and you can get cracking and popping, and basically the LED will destroy itself as the moisture boils out of it. So that's not a good thing. So anyway, yeah, I've had quite a few times that I've had LEDs. So what you can do is bake them. Sion has fitted so many thousands of these LEDs that I'm sure he's there in the comments explaining how to fix the problem, but basically you can bake it. Yeah. Johnny says, I do my reflows on a heat plate. Yep. Yes. Oh, Peter says, I need a BRAM upgrade. Yeah. Is that brain RAM? I most definitely do. Yeah. Brains are weird things. They can vary so much between people. And it's taken, like, everybody's got limitations in the different ways their brains work. I have some big limitations in mine. It takes a long time sometimes to realize it. You can go through a large part of your life and just not even realize that the way your brain processes things or does things might be a little bit different to the way other people's do. So there are certain things that I find really hard just because of the way my memory doesn't work. One of them is learning languages. Doing anything that requires rote learning, my brain does not handle at all. So a few years ago, I did some of the private pilot's license stuff. And one of the big difficulties that I had was memorizing pre-flight checklists. So for a typical light aircraft, you've got this checklist that you go through, and it's all the things you need to check, obviously, as a safety precaution before you move the aircraft and before you're ready for takeoff. And the checklists vary, and they could be 20 items or 30 items or whatever, depending on the aircraft type and all sorts of other things. But so I would do things like try to memorize the pre-flight checklist, which is, say, 25 items, and I couldn't do it. I would spend ages with the pre-flight checklist printed out and just going over it and over it over a period of weeks, and I could not memorize a 25 item list. It drove me nuts. And so I kind of gave it, that was one of the things actually that made me understand a little bit more about how my own brain works. So I'm aware that that's a limitation, which is also one of the reasons that I have this coping mechanism of things like these notebooks everywhere, and I write stuff down. It's quite common, for example, that I will be doing something on the pick and place machine and I'll think, I don't know, I'm trying to think of an example, and I will think, okay, here's a good one. What is the command, the G-code command, to turn on the coolant on the, which is actually used for the, I've got the coolant output on the motion controller set to run the air pump for the vacuum. What is the command for the coolant? And I've just written down here, it's on is M4 and off is F5. And later I will, the thing is that I don't even remember that I've noted that. So what will happen is that maybe 6 months later, I will come along and I'll be trying to work on the machine and I'll be thinking, what is the G-code command to turn on the pump? I've got no idea. And then I'll flip back through the book and I go, oh, I wrote it down. I don't even remember writing it down, but I did because I thought, hey, I might need this information later. All right, what are we doing? We've got a board that we need to put some more things on it. Let's switch to overhead because we need some connectors. Switch, come on. I click the button. You can do it. You can do it. Yes. Okay, now, maybe I should get some more zoomage on that overhead camera. I need to set up a way to control this zoom remotely. At the moment, it's a, it's gonna wobble for a little bit until it stabilizes. So at the moment, that camera has a zoom on it, but it's not a power zoom. So I've got to reach up and move it. Oh, it's jiggling around and making me seasick. All right, so I need I need the alternate connector that this plugs into. I need some headers and I need a D1 Mini. My soldering iron is on. So, and I can probably use the D1 Mini that was already used in this project. But over here, I need DB9 connectors. And I need the plug, not the socket. What order should I assemble this? Should I do the other headers first? Yeah, I think I should. So that's going to go on there. And then the multimeter plugs in there. Now this part of it, where am I up to? 10:35. Yeah, I do want to get onto the pick and placing stuff because that's kind of cool. And it might take a little while, so I don't want to end up with 10 minutes left at the end and still be getting to that. But this is a project that has been going on for a very long time. Oh, right here on the bench I've already got a few things lying around. I think these were from when we were working on it previously. Now, headers. Let's see what clearance we need. I'll see if I might find an 8-pin header. Now, if I put that on there, and that goes on that way, we will check the clearance. Ooh, just skims down the back of the connector. Very nice, just as the 3D model suggested. Oh, so what I've been wondering is whether I will need, I kind of do. So these two boards don't quite clear each other. You can see with the single plastic spacer, which is 2.54 millimeters thick, there's not quite enough room. So I think what I'm going to do is double up the plastic on the side here. But what I'll do first is grab another 8-pin header out of my little header cache here. I've got bulk supplies of all of these things, but this is just my, oh, that's what I need. In fact, that's both of what I need. This is my local scraps box. So I've got everything within easy reach. So what I'm going to do here is, I'm going to use, this is a spare bit of plastic off some of these headers. And I'm going to cut that into a couple of pieces. Cut it up into pairs. It's 8 long, so now I can feed that onto here. Pins are sliding through. You can't really see what I'm doing, but I will show you in just a second. I need that bit of wood, so I'm not jamming holes in my anti-static bench surface. Okay, so there you can see that I've added an extra bit of plastic onto the header so that the space between the two boards will be twice what it normally is. And then I'll do that on the other header, which is here. Just jam that on. Which way? That way. No, missed it. Okay, so now we've got two that are double height spaces. I'm going to get rid of that for now. And stick these on. Which way? That way. So now the spacing between these two is enough that it easily clears. And it also has the side effect that it brings the antenna up away from this base PCB. Now we've got on the bottom PCB, you can see there's this big square where the copper has been kept off it, and that is to reduce the interference, well, not the interference, the ground bias that it applies to the antenna, or to the signal. But still, having a bit of extra space here will help. So, time to do a little bit of soldering. And why won't, oh, that's why I've got parts on there. Grab my solder. I almost need new solder. So look at this, I'm on the roll of solder, and this is on the last layer, and I'm working my way along towards the end. So that was originally, I think, a 1 kilo roll of solder. It's lasted a few years. Come on, got to get both these sets of headers in, get it all straight. There we go. Now, I'll just tack a couple. Now, you can see there's smoke wafting up here. Normally I would do this over in front of the extraction fan, which has got a carbon filter in it. But then you can't see what I'm doing. So, I'm making the lung sacrifice. I need to get back and check the chat in a minute. It'll be really cool to have someone else in the room with me, because while I'm doing things like this, I can't really watch what's going on with chat. And if I had someone else in the room, they could read the chat and relay things, turn it into a conversation. See, now I've stopped talking because I'm soldering. I know soldering doesn't really take much thought, but I just sort of get into the zone of doing it and forget about the fact that there are people sitting there watching this on their screens. Okay, so let's make this even trickier for me. I'm going to try to mentally multitask. So yesterday, some of you might have seen on Twitter, I posted some photos of the emergency staging area at Kalorama Oval, not too far from where my mum lives, and I was there yesterday. We were doing things like clearing out her fridge, because she's not going to have power for another 3 weeks, and it's been what, 11 days already, so she's going to be more than a month with no power. And the point I was wanting to make is, at the staging area, oh, I missed one of the pins. At the staging area, there was this really cool service. Like, they had lots of good things there. So they had places set up for food and places for people to recharge their phones. Because if you're stuck for weeks with no power, then having somewhere to do a quick recharge is really handy. It's cool. That's done. So I'm going to stick the other connector on. Yeah, so having somewhere to recharge your phones is fantastic, because most people don't even have landlines anymore. And if you do have landlines, typically you'll have a phone that requires power. A lot of people have things like cordless phones, or like decked cordless phones, and they're not powered by the line anymore like basic phones are. So even if you have a line that works, you don't necessarily have a landline phone that works. And one of the and they had gas bottles, you know, the standard barbecue type gas bottles. There was a huge rack of those there, and they were just swapping gas bottles for people. And so if you had ID that showed you lived in the area, you could come along with a barbecue gas bottle and swap it over and use the barbecue for cooking. And they also had this service from a charity called Orange Sky. It doesn't look quite straight. Don't know if you can tell. Oh, no, yeah. If I align it this way, it's like the this side of the connector is just very slightly angled up. It's pretty close though. It's not really obvious. So anyway, this charity called Orange Sky, what they do is they've got washer dryers set up in the back of vans with all of the plumbing and everything that they need, so they can run. It's basically like a mobile laundry. And they, what they normally do is provide free laundry services to homeless people. And so they have been taking a couple of their vans up to the storm-affected areas and giving people a chance to wash their clothes, which is really, really cool. But quite apart from the fact that it's cool they're providing it for the people affected by the storm, is the fact that they do this daily for homeless people, which is a fantastic service. So I had never heard of the charity Orange Sky until yesterday, but I'm very impressed. And the person we spoke to from Orange Sky was really super helpful and very nice. Now, the next thing with this, I'm doing a quick mental debate about whether to test this now or whether to just get on. I think I'm just going to get on to doing the pick and place stuff, because I don't know how long that's going to take, and things can probably go wrong and we might end up with stuff setting on fire. So this is an implementation of a circuit that we've already had running on the breadboard. So we've shown that the circuit works. If I've screwed up the implementation of the PCB, it's not going to work. And yeah, okay. I think what I'm going to do is put this aside for now. We've seen it assembled. Let's switch back to the front camera and I'll wave it around there. So we've got focus. No focus. So we've got connection in from the multimeter, USB for power, and also data can come out here, and Wi-Fi on the ESP, so it can publish multimeter readings to MQTT or whatever you want. So I came here today to do some pick and placing, so I'm going to get onto that. Now, this is where things can go seriously off the rails. Let me... Johnny says we won't tell it's crooked. Yeah, oh, Scott said Jerry Ellsworth used to have a text-to-speech unit on her IRC while streaming. It was kind of annoying. Yeah, I think that would get annoying. I think what you'd need is a person in the room who is watching chat and then talking to me. So that would be awesome. Now, Andrew said, that's the problem we had in Christchurch. This is talking about the phone situation. That's the problem we had in Christchurch after the 2011 earthquake. People with power requiring landline phones. Big call for people to donate line-powered phones. Yep. So the standard telco issued phones that you just plug in. They don't need a plug pack or anything in the wall. You plug them in, they get their power off the phone line, and they just work. So that's what you need in that sort of situation. Now, what I'm just going over in my head is how we are going to do this. I need to switch to a portable camera because otherwise you are not going to see a thing. Okay. Let's see. I've got 80% battery on my phone, so I should be able to go Droid Cam. I'm going to stick this up here. And where am I going to? Oh, that'll do for now. I'll just wave it around, and this is the bit where I suddenly start thinking about what things do I have visible that I don't want to show on a live stream. Yes, come on. I've tried switching to portable. Come on. Oh, there it is. That was just OBS taking a very long time. Let's see if there's any lag in it. No. Okay. It was just OBS taking a really long time to switch. Now, I'm going to give you a little bit of a... I'm going to step back and give you a little bit of a view around so you can see the context of what's going on here. So that's the workbench that we were just doing the assembly on. And if we aim it up, you will see the downward looking camera and the computer. And moving around to the left, you can see, oh, hang on. Oh, the screen just went blank on my phone, but that's all right. So there you can see the pick and place machine, and just to the right of it is a screen that you can see location. That is the Ubuntu machine. So down underneath the pick and place machine, or kind of inside the frame, there is a motherboard. And that's like a PC motherboard running Ubuntu, and then OpenPNP is running on that, and the screen is sitting just to the right of the machine. So when I'm sitting at my computer, just here, I have the workbench to my right, and then the pick and place machine is to my left. And then you can see there's a stencil thing to the left of it, and this is the machine. So there are a couple of boring things that I did before the live stream. I'll show you what they are so you know what's going on. Now, first, this is one of those things where it's very hard to show you, but unfortunately I don't have access to share this screen because it's on a different machine. But this is the OpenPNP interface, and it's got a list of all of the parts here that are on the PCB. So what I've done is I've preloaded the board and I've assigned all the parts. So we've got all the resistor networks here, fiducials, LEDs, that sort of thing. And there are some parts you can see that aren't enabled. Those are, what have we got here? These are some ICs that I'll put on by hand. These ones are just jumpers, so they don't need placement. Here are some capacitors that I'll put on by hand as well. All right, so where I got up to was setting up stencils. This is what I was rushing to do just before the live stream, and that is the PCB for the 16 port version of the breakout. And what I've done is I've just used this Kapton tape to attach some old PCBs on the edges here, and it just provides a place to locate the PCB. Really crude, but close enough, and it doesn't really move around. I haven't put one on this end, so it can move that way, but I'm going to wipe it in this direction, so that'll be fine. It'll be close enough. It's all a bit of a bodge job. Okay, so now coming back around here, what you can see is the stencil sitting in a frame. So it didn't come framed. This is an old frame for another project, and I just cut the old stencil out of it, and then I just reuse this frame and tape in whatever it is that I want. You can see it's a brand new stencil. It's still got the plastic across it. And if I turn you upside down, you can see the stencil is just kept on taped into the frame. Not even at a very accurate position. But one thing I do need to do is get this plastic off it. Now, it costs a bit extra in shipping, so you can get these stencils with just as a sheet of metal and no frame, or you can get them already bonded into the frame and pre-tensioned and everything. And getting them done in the frame is much nicer, but it costs more for both the stencil, because I have to do all the framing, and it also costs more in shipping. So for boards that I'm just going to assemble a couple of them, I normally just get the stencil as the sheet. There we go. Did I get it all? Yep. Yeah, I just get the stencil as the sheet without the frame, and then I just tape it into a frame that I reuse. If it's something that I'm going to make a lot of, I get it done with the frame, because then it's all properly bonded. They pre-tension it and everything. It's really nice. In fact, I can show you another one. So this is what it looks like when they do it properly. And you can see they've used this, what they've done is they've glued the metal down and it's tensioned. So this is like tight as a drum. I don't know how they do it, but they somehow tension it out in all directions while it's being bonded and glued and then taped over. And then on the inside, they run a bead of something that seals it around here. So when the solder paste is used in here, the frame is totally sealed. And I think it's some kind of like an epoxy. It's not soft like silicon. It's a little bit brittle. So it's quite hard, the stuff that they use to seal this. But yeah, this sort of quality is really nice. But shipping that costs a lot more than shipping a flat piece of metal. So, back to here. You can probably tell, but I'm feeling a bit off today. I don't know why. It's just one of those things. This is the sort of setup that I was hoping to have done before. Yeah, before the live stream. I've just got to try to find the position of the, I think that was it, yep. So you can't really see, unfortunately, but what I'm doing is just moving the baseboard around to get the PCB into approximately the right place. So it's about there. And then I can make fine adjustments later, as you will see. So next up is off camera. I'm just grabbing myself a chunk of the Kapton tape. And I'll just attach that to the base, and I'll stick another one up at the top. Yeah, I normally spend my time alone. Like when I'm working, I'm just here in this room, not talking to anyone, doing whatever needs to be done. And so when I'm doing live streams, I normally try to artificially inflate my energy level, I suppose. Hang on, I'm going to bring you over here. But looking down through here, you see how there is silver visible in that area just there, in that hole. That silver is the exposed pad. And you can see if you look across here now, there's silver visible all the way along. Now, if the PCB wasn't aligned, you would see the silver would be, well, if it's not quite aligned with the pad, you can see it's a little bit low on this side. I don't know how well that's coming through on the camera, but there's a dark line just at the top of the aperture. And that means the PCB is slightly low. So I need to move the PCB up in that direction. Up at this end of the PCB, the alignment is better. So it actually needs a slight rotation like that in order to get the apertures to match the pads under the PCB. And the way I can do that, now that I've taped this down, is just with a very slight adjustment of these. And that's it, that's fixed it. So what I did was I just took the screw out a little bit here, and I brought this screw in a little bit, which just shifts the bed ever so slightly. So that is now aligned, so the stencil is now aligned with the PCB. Next step, solder paste. Get out the old chip quick. So that's the solder paste we're going to use. Got a scraper here to put it on with. Just need to grab myself something to dish the solder paste out. Yeah, so as I was saying earlier, it's actually really tiring doing live streams because I work hard to artificially inflate my energy level. Otherwise it just comes across as if I'm either asleep or bored or whatever. So I'm just going to donk a bit out here. The camera has very much a flattening effect. So when you're making a video, it can very easily feel like you're projecting yourself normally when on the other side of the camera it seems like you're being really slow and quiet and not really speaking up properly. Okay. I was going to wipe it this way, but I think I might be better off actually doing it that way. Yeah, just because of the proportions of the board. So I'm going to stick a bit more solder paste around here. Now solder paste is a really weird thing. Let's see if you can see this. It's specially formulated, so you can see that it's kind of standing up by itself. It's formulated so that it's quite stiff in normal conditions, and when it's put under pressure it becomes liquid, which is counterintuitive, but it's the reason that's done is that when the pressure is applied with the squeegee, so you can see here that it's all kind of standing up. It's not slumping down, it's maintaining its position, including some very small features. But if I wipe this, as the pressure is applied, it sort of becomes temporarily liquid. Oh, I don't think I got that last bit. So that it can flow. No, I didn't get very good separation. All right. Let's see how this goes. No, this is not working too well. I think I'm going to end up with some, let's just chuck it under the microscope and have a look. But I think I'm going to end up with some bits. Oh no, it's actually looking better in real life than it did. Okay, what am I doing now? Back to microscope. Yeah, you can see the alignment wasn't crash hot, but it's okay. So you can see the solder on those pads. So the PCB could have moved a little bit to the left to get the alignment spot on. But we now have solder. Oh, was there? Oh no, it was covered. Looks like I did get proper separation, which is good. So we now have solder on all of those pads. Hooray! Well, that's a good thing. Oh, just got to switch back to the other camera. Portable. All right, so what I've done is I have just dropped the PCB into the carrier on the machine. And now things are going to get a little bit noisy. All right, I've got to think through the sequence of what I'm doing here as well. This is super dodgy. I've got a battery sitting up on top of the gantry here in order to run the illumination for the down camera because I need to run some cabling. Now the bad thing about this is I'm going to have a fair bit of noise. I'll delay turning on the vacuum pumps and things as long as possible. So first step is, so you can't see me, I'm just off camera over here at the machine with OpenPNP. So I'm going to first off turn the machine on. So what it's doing now is opening communication with the motion controller and you can see it's now homing the unit. So it homes the Z-axis first, then the X-axis, then the Y-axis, and then it will do an optical home. So right now what it's doing is using, there are optical limit switches to get a rough 0 position. And then it will move to an offset if it works. Here we go. And then it's just done an optical home against a fiducial. And if I pick the camera up and move it. So looking into the machine there, you see the little block just in under there. There's a squarish block with rounded corners. That has a fiducial. It's stuck to the board in a reference position and it has a fiducial on top of it. Now if we come sideways across to OpenPNP, that is the camera view looking straight down from the head at that fiducial. And what it's done is it's homed itself using the normal optical limits and moved itself to approximately this position and then used visual homing to find the location of that mark and then recalibrated at 0 position. So that way we get an accurate 0 every time. So I'll move this back over to here. I want to get it into a position where you can see as much as possible. Now the feeders that matter, I might even move it to the other side. The feeders that really matter are this one and this one. They don't have labels on them yet because I only just set them up yesterday. That's got the 1K resistor network and the 10K resistor network in it. And we're going to place some LEDs as well, and I think some other resistors Oh yeah, it's going to place 4K7 for the I2C pull-up and a couple of other things. This is the up camera for doing its position correction. And I think we might be just about ready to go. All right, I'm going to turn off the blow-off pump. I'll turn on the blow-off pump, which adds a bit of noise. Now before I begin this, I'm just going to check the position of the board. So let's move that. Yeah, it's not bad. I'm just having a look at the fiducials through the overhead camera. And it's close enough. All right, now I'll just park it for a second. So this is where we're going to begin. So first thing I need to do is I need to turn on the feeders. Ah, damn, I've got a communication error from the feeder controller. What that means is I've got to start the machine again. There is a, yeah, that sucks. I may even have to reboot OpenPNP. It happens sometimes. Error reading from controller. Yes. All right, let's try again. Power on the machine. While we're waiting for that, I'm going to turn the blow-off pumps off. All right, I'll try turning on the machine again. So, to explain a little bit about what's going on here, the machine is controlled by a PC running Ubuntu with OpenPNP, which communicates with 3 different devices that run the actual hardware. One is the motion controller, which at the moment is a tiny G, which is down in there. You can see the green LED. That's what moves the, basically that's what moves it around. Then down the back there you can see there are 2 of the vacuum pumps, and you can see a couple of aquarium pumps there. So the aquarium pumps are used for blow off. So what I do is down the back there are some vacuum solenoids, and those are controlled by another board which is under here. So there is an Arduino under there with some MOSFET drivers that control the vacuum solenoids and power to the pumps. And what that allows it to do is to select either vacuum or positive pressure through the nozzle by switching those solenoids. So that under there is the second controller. And then around, I'm going to turn you sideways. Right under there, there is another Arduino, and that is controlling all of the feeders. So what happens is that there are essentially 3 USB connections to the host computer, and when OpenPNP starts up, it opens all 3 serial connections and begins talking to those controllers using G-code. Now, I'm just going to move that over there and try activating. No, I'm going to have to restart this. So this is one of those situations where we should already be placing components by now, but sometimes these things go wrong and this can be a bit flaky. So I'm just trying to quit out of OpenPNP. And the other thing that has been really annoying me recently is that I think I've got, I'll move the camera so you can see both a little bit. I think I've got a problem with the disk that's on this controller. I'm wondering if I should reboot. So if I reboot, there is a very good chance that this computer will not come back. I've got disk errors occurring. Let's just try starting OpenPNP again and see if the controllers communicate this time. So the motion controller is loading. That seems okay. But what I don't know yet noise weather. That's it, so visual homing done. Now, can we enable the feeders? No, damn it. That means I am going to have to reboot the computer because it can't see the serial port. Yes, 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 I know. Yeah, this is what happens when you have a machine that is a project and not a tool. You end up messing around with it, just trying to make it do basic things. All right, shut down, restart. And we'll see if its disk comes back. So, while I was doing that, what is going on in the chat? Mitchell said, have I seen Index PNP? Yes, I have. I've been watching Stephen's videos. Johnny said, have you tried turning it off and then on again? Yeah, that's what we're doing. Oh, we're, at least the computer rebooted. That's a start. Aaron was talking about these feeders and whether they could work with the Index PNP controller board. Well, hang on. Sorry, I'm paying attention over here as well because it's rebooted. I'm just going to try connecting to the machine. Doing its homing. All right. Yeah, no. Yeah, Stephen's doing a really interesting, he's doing a really cool job and I like what he's done. But Jack's Tech said, in regards to comment reading, have a mod on a Discord PTT channel fed into an earpiece. Funny thing is, what you are describing there, oh come on, is actually one of the reasons that I got the second Rode microphone set up. It's so that I could run an in-ear monitor. Because with the Rode microphones, you can run them backwards. Basically, you can flip them around and use them as a transmitter from the computer to you, which is the reverse of how they're normally used. And then I could have an earpiece and be wearing the receiver instead of having the receiver at the other end, at the camera end. Sorry, I'm distracted because I'm also trying to get this machine going. Just running its homing again. Yeah, there is a... okay, no, I wouldn't use Stephen's controller. What he's done is really cool, but he's done a kind of integrated design, and what he's got suits the way his machine works. Oh, that's better. It's just homed itself. Now, can we talk to the actuators? Try this again. Yes! Actuators are enabled. All right. Back to portable. Okay, so what I've just done is enable the actuators, and you can hear them kind of ticking and buzzing and whining and making funny noises. I'll load the job. And then we've got all the parts, so let's have a look at one of the fiducials. Looks okay. And now let's get on with running this job, and we'll see how badly it stuffs up. Now, one of the other problems I've just been having recently is I've been having alignment issues with the right nozzle. So I've disabled it, which means that right now I'm only running with a single nozzle. It reduces the speed of the machine by about 30% or so, give or take. And now things are about to get noisy because I'm going to turn on the vacuum pump. On. I'm going to narrate as I'm doing this, but I don't even know how much of this you're going to hear. So what it's done is picked up the first part, moved it over the overhead camera, and then corrected for the alignment. Because the parts often end up slightly misaligned as they come out of the tape. They can move around a little bit. They're not always spot on. So doing the bottom vision allows it to correct for that. So it's putting on a bunch of 4K7 resistors at the moment. And as you can see, it's only using the left nozzle. It's not picking up anything with the right nozzle. Oh, that's an LED going on. What was that one? Blue one, blue LED. And should be a green LED. And now it'll do a whole bunch of resistor networks. You can hear some sort of squeaking noise coming out of the chassis there, which is not good. It's some kind of a harmonic, depending on the speed at which it's moving. This whole machine is not mechanically optimized at all. The base chassis is it's based on an X-Carve CNC machine, which is why that head is so large and heavy. It's for something like pick and place, what you need is a very light head and to minimize the moving mass. So keep all the motors off the head if you can, move the motors off the axes that they're moving, and that allows it to go much faster. But this is a very heavyweight machine because it's got that large head, which is designed to be rigid for CNCing. It's designed to take lots of lateral force, and we really don't care about lateral force on this. It's just picking up things that weigh a gram or less. All of the mass is in the machine itself. It's not in what it's picking up. Now, while that's running, I'm going to do something very dangerous and stop paying attention to it. No, actually what I'll do is, while it's running, I'm going to move this camera for a second because I want you to see what's going on the screen on OpenPNP. Look at this. So you can see that it's showing the pictures of the bottom vision. So each time it places a part and does its alignment, it'll do another one sometime. It should update that image. There we go. And you can see the bounding box that it's drawn around the part. Oh, something's gone wrong. Oh no, I don't think it has. I think it's just, yeah, it was just having a little thing. So yeah, you can see that what it's done is the up camera has found the outline of the part and drawn a bounding box, which then allows it to figure out the correction for the alignment. And it applies, oh, that one, it's got a fair bit of rotation on it. So hopefully the parts will end up reasonably well aligned. Oh, I can already see that there are some that are offset to the right a bit. I think that's because I was being kind of sloppy with the board position, and I didn't run the fiducial alignment for the board. Only got everything, 6 components to go, I think. Oh, I've missed a couple of pickups. What is, oh, I see what's going on. Yeah, we've got a problem here. And it's not detecting the failed pickups either. I'm gonna have to put those on myself. I wasn't watching, and the tape has peeled. The cover tape didn't quite come off properly, and it was covering the part. So when it tried to pick up the part, it was covered by the cover tape and didn't pick it up. So at the moment I've got no vacuum detection, and for some reason when it's doing the bottom vision, it's not failing when it doesn't see a part. Anyway, these are all things that I could spend time fiddling with. Oh, it's done. Cool. But before I pick that up, what I'm going to do is use the little vacuum thing, and I'm just going to pick up these mispicked, well, these resistor networks that failed to pick. I'm just pulling them out of the tape manually and dropping them on the board. Not even trying to align it. Oh, come on. Don't fall down there. I think I'm going to have to use tweezers to get those. So I'm just going to put those on manually. So yes, what you're seeing here is lots of fiddling with things that shouldn't require fiddling. But what I find is that it tends to... This is the first one of this board that's ever been done, and and I've only just put those feeders in yesterday and just loaded those resistor networks for the first time. Let's switch to overhead. Yeah, and there are always these little teething problems, like the tape cover tensioner is obviously not quite right on those resistor networks, so it wasn't peeling it back properly. Now, because this noise is very annoying, I'm going to turn this off. What have I got? Disable feeders, blowers off, and that's it. I can just leave that machine for now. Yeah, so we've got these resistor networks that weren't picked up properly. So we've got some general issues, but what I usually find is that, you know, I do a little bit of tweaking, and by the time I'm doing the second board of a particular type, it'll be fine. Those sorts of things get ironed out, and if you're doing a few in a row, then by the time you're a couple of boards into the process, everything's going quite smoothly. Now I'm just going to, which way? Move that. You can see there's a capacitor missing up the top there. That's one of the ones I've got to put on manually. I don't have those in feeders at the moment, but I do need to place these. So down here on the PCB, this is where I chucked all of the resistor networks that weren't placed. They were the ones that were left just lying around in the feeder tape. So I'll stick those in place. Where's that one? There, and one up there. That's it. Get focus a bit better for the camera. Alright, so you can see that they are offset slightly to the right. The position is not really that great, but what I'm going to do is just leave it all there. I'm not going to correct the positions. I'm not going to sit there and nudge all of these parts into place. And so surface tension should fix those. They're close enough. Yeah, those ones are a bit misaligned. Alright, so what have I got to do? That's right, I need capacitors. So I'm going to chuck on some 10 microfarad 0805s. I've got a couple of those to go on. There's that one there. there's basically one of these near the supply line. You can see here, this is where the MCP23017 is going to go. That's the supply rail for that. And there's a, oh, come on. There is a 10 microfarad 0805 just adjacent to each of those. Oh, I nearly manually tombstoned it. What else have we got? Okay, I need to put on the big caps and I'll put on the MCPs. And then we can stick it through the reflow oven. I haven't been paying attention to time. What is it? 11? Yeah, we're going to have this board all done. 11:30. So I need MCP. Got to find them. Where did I stick them? I've probably got them out somewhere because, oh yeah, I do. Because I was using them. They were sitting up on the bench instead of being in their normal put away location. Now what have I done with scissors? So, now these parts are big, so I'm not going to do them under the microscope. I'm just going to switch to the overhead camera. Alright, so that is the board in all its completeness, almost. So I just got to chuck a couple of these chips on here. Time to switch tweezers. Yeah. I'll probably need to nudge the alignment a little, but I'll just get them basically into place first. So, quick microscope check. Pretty close. And in just a moment we're going to go portable again. Oh, that's right. No, I need some... Oops. I need some capacitors to go on here. And I've got those hanging around up here. So I've got these big reels of capacitors just hanging here. I'll grab out a couple of these. How many do I need? 2, that's right. It's 1 per port, isn't it? 1 per batch of ports. So 1 goes there. 1 goes there. And then I think it's reflow time. So I'll do this one in the oven. I'm not going to just wave the hot air over this. So it is time for us to go on a little journey back to portable. Here we go, like Casey Neistat style. We're talking with hands in front of the camera. Wandering around here. Okay, so this is the little bathroom at the back of the office. And you can see there's a reflow oven there. Now, let's see what I can do with getting a reasonable field of view here. And you can see one of my 3D printers there as well. So, all right, so what we've got is the board is in the oven, and I've got a couple of other old boards there that I just used as thermal ballast. They normally just live in there. So I've got to select the reflow profile and start it. So the heater has started. Oh, also I've got to turn on the extraction fan, which is just behind the camera. All right, the fan is now running. Now, what you can see here is the reflow oven is sitting inside this wooden, open-fronted wooden box. And it's basically acting as a fume cabinet. Hang on, I've got to put the camera down so it stops jiggering around and fix the arrangement a little bit, the alignment. All right, here we go, that's better. All right, so reflow oven is here, and then it's inside this as a fume cabinet. So what's happening right now is the silver thing that you see over here, there is this big vent that is going to an extraction fan which is up inside the ceiling, and it vents outside at the end of the house. So that is sucking air through this cabinet and then venting it. So what happens is that fumes that come out of the oven basically just get sucked through there and exhausted. And the nice thing is that this actually works really, really well. I used to have a really big problem with fumes from the oven, but with this in place, I don't get anything. I can stand here and I can't even smell, I can't smell a thing, can't even tell that it's running. So that's a big improvement. The other thing over here you can see is the ultrasonic cleaner. So that's got some fluid in it that helps remove all of the flux residue and whatever else there might be. So once the boards have been baked, they go into the ultrasonic cleaner and or flux removal, and yeah, then get rinsed, and then they go into a dehumidifier. So I've got a box, it's actually like a food dehumidifier, and that they basically just sit in there. I think they sit at like 50 degrees or 55 degrees, and I leave them in there for a couple of hours, and they end up perfectly dry and clean. So they come, boards, once they've been through that process, they end up spotless. They come out looking really shiny and nice and nothing left on them. Okay, now that's going to take a little while to run. So while the oven is running, I think it takes about 7 minutes to do a cycle. Let's see. Okay, so Aaron pointed out that the reset pull-up pads are empty, not sure what goes there. Nothing goes there. That is a solder jumper. Now, one of the last changes that I made on this board was that I replaced a whole lot of solder jumpers with pin headers. But one that I did not replace was the reset pull-up pads. I left them as solder jumpers because I think that's something that is not going to be changed very often. Aaron said, or it's an ultrasonic cleaner. Oh, draft on tap would be awesome in the man cave too. Yeah. Okay, so Dodgy said, when you reflow, why don't pieces slide around the board? They always seem to fall to the right place. And Mike Brown very correctly said surface tension of the solder. And Dodgy said, so provided you get the solder in the right place, it will align it. Yes, that is pretty much what happens. So what you can do is, within limits obviously, but you could put a part down so that it is offset. Say it is normally aligned with the pads, but it was offset sideways by like 50%, so that it was partly overlapping the pads and partly not overlapping the pads. When the solder reflows, the part will just go zhwink and be, I should sell a sound effects track, and be sucked across and aligned perfectly with the pads. So that is, demonstrating that is actually one of the reasons that I deliberately did not nudge the parts that are on that board. So as we saw under the microscope, quite a few of those resistor networks were offset to the right a little bit. They weren't massively out of alignment, but they were, you could tell that if you looked at them, you could see very visually they were off to the right of where they should be. So the interesting thing now is going to be, once we get that board back out of the oven and it's had a little bit of time to cool down, that's something I didn't allow for. I normally let it sit there for a while to cool down, but I'll take it out while it's still pretty hot. what we should see is all of those resistor networks should be absolutely perfectly centered on all of the pads. And that will show that the surface tension has pulled them into position. Scott Miller said, too bad it won't fix the random orientation. Oh, was that, when you're saying random orientation, is that the complete 180 degree rotation of the parts so that the labels all align? Because one thing I've noticed is that resistors in normal resistors, like 0603 resistors in tapes, tend to have all of their labels aligned the same way. And this probably depends on the manufacturer, but the ones that I've had anyway. So if you look down a strip of resistors in a tape, all of the labels will be aligned the same way. One thing I've noticed with these resistor networks is they're random. They're one way or the other, and it's just different. There's no consistency whatsoever. So however their machine goes about packing them into the tape, like presumably there's like a vibration feeder, and all of the little resistor networks would be sliding down a funnel, and they get aligned, and then they fall into the holes in the tape before the top cover tape gets put on. It's randomized. So yeah. Okay, let's have a look at, well, I'm going to do a little bit of cleaning up first. We'll give the oven another minute or so, and then we'll go and have a look at what's happening with its heating curve. So it doesn't tend to follow the heating curve. Basically, that oven does not have quite enough power to get hot quickly enough. So the desired curve is always a bit higher than the actual curve. But it doesn't matter. Basically, the actual profile that it follows, the profile that I've selected in it, when it runs, even though it's not getting to what it's trying to get to, what it does get to works perfectly well. So the actual curve, I just heard the fan change. That's one of the giveaways. Because I've run that oven so many times, it's in the background. I don't know if you can hear it through the microphone, but the fan on the oven changes speed. And so when I hear that speed change, I know that it's got a certain part in the cycle. It'll be into the soak part right now. And in a moment, it'll probably go, it'll go through a spike, and then we will get some cooling happening. When I hear the fan ramp up again, I know that it's on the cooling part of the cycle. That's it. There it goes. Let's go and have a look at it. I'm going to switch to portable camera again. Now, if you look at the chart shown on the screen there, you can see the bold asterisks are the actual temperature, and the thin line is the desired temperature. You can see that during the heating part here, it hasn't heated up quickly enough to follow the curve. But at this point it catches up. So it doesn't give it as much of a soak cycle as it really should, but it's not bad. And you can see that now it's on the cool down part of the curve. Now, another limitation of these particular ovens is that they don't vent the air quickly enough. So what will happen is, even though it's running the extraction fan now, that temperature is going to lag the desired temperature again. It's going to stay a little bit hotter than it should. You might be able to just see now that it's starting to deviate. So the actual temperature is above the desired temperature because it's not evacuating the hot air quickly enough. So what I usually do is, when I hear that fan change, which is what made me come in here, is I come in here, once it's dropped a little bit, I just grab the drawer, pull it open about 1 centimetre. And that is enough to improve the airflow through it, and now it'll be able to follow its cooling curve a bit better. But one thing to be very careful of is that while the temperature is high, while they're still at this hot portion, the solder on the board will still be molten. So it's if you bump anything at that point, you can actually knock components out of position. So what I do is wait until the temperature has fallen a bit, it's come down the curve, and then I just pull the drawer open a little, and I do it smoothly and slowly so that I don't bump any parts. And you can see now that the curve after its blip is now tracking a bit better against the desired cool down. And it's cooled down a fair bit more now, so I'll pull it open a bit more. And we will let airflow do its thing. So that board now, all of the solder will have solidified. We could safely pick it up and nothing would move, except that I would burn my fingers if I tried, because it's still hot enough. And that's the oven telling us that it's done. So what I'm going to do is grab a pair of tweezers so that I can pick the board up without burning myself. And I'm just having a quick look at it. Just a quick inspection here. It's actually looking pretty good. So I'm going to grab the piece of wood that I use under the hot air and a pair of tweezers so that I can transport this. So I'll try to pick it up without touching it. Where can I grab it? There. Oh. That's it. And I'll just leave the oven running with its extraction fan on so that it'll cool down. So now we'll do the Casey Neistat walking with their hand in front of the camera thing again. And try not to drop the board on the way to the bench. Bashing into things on the way. And back to overhead. Come on, camera. Switch. You can do it, OBS. There we go. So now we have our freshly baked board with all the parts on it. Well, most of the parts. We don't have the pin headers that I will need to solder on by hand, and we don't have the RJ45 sockets or the box headers that go on the end here. But let's have a look at this under the microscope and see what it's done. Come on. This sort of delay is hopefully what I won't have once I've got the ATEM doing its job. Is it going to switch? Yes, there. It takes that long just to switch camera views. Alright, so that is looking pretty good. I'm sliding across so I can see on screen what you're looking at. Yeah, you can see those resistor networks are perfectly aligned with their pads. I'm just going to scroll across here, slide sideways across all the networks. Oh, looks like there might be a couple of solder bridges there. That's interesting. I can see 2 solder bridges, 3 solder, 4, 5. That's really disappointing. All right, and just in case you can't see it, right there, see between those 2 pads, there is a solder bridge. So I'll just touch that with the iron, touch that one, get rid of that bridge. And this one. And here. Oh, I just realized these bridges don't matter because, in fact, that one I'm not even going to bother fixing it. This is on the common side of those networks. So these bridges mattered. And I wonder if that's a joint that hasn't flowed properly. But if I grab a pointer, if you look down this side, see this is a common, this is the pull up. Yeah, so this is a pull up. So this side of all of the resistor networks is actually just joined together. So solder bridges in places like that don't matter. But there it does. Yeah, there are a lot of solder bridges on this. And what you can see here, see this residue? That is the residue from the flux that's in the solder. And if I scrape it here, you can see all the little yellow flakes coming off it. Now that is the sort of thing that gets cleaned up by putting it into the bath with the ultrasonic cleaner with the solder paste. No, not the solder paste. See, I just say random things if I'm actually having a fair bit of trouble seeing this, because one of the difficulties here is that the focus for the camera on the microscope does not match the focus. Look at all these bridges. That's terrible. I definitely got too much solder paste on it. That's something that needs to be improved when I assemble more of these. Now, there are a few different ways I could fix this. Anyway, that's right, the difficulty I'm facing. So right now, I have focused this so that the camera is in focus, but the eyepieces are not. I'm actually looking at this and everything is blurry. So I'm kind of not being able to tell what I'm doing. What I need to do is I need to align the focuses so that when the camera is focused, the eyepieces are also focused. Yeah, what I should do is get some flux paste or something onto this, do it properly. This is also I've got to keep an eye out for solder bridges on the chips. I don't see any there. Yeah, what I was doing before was just randomly looking around the board, but I really need to be methodical about this. So start in the top left corner and go sideways. So first row of parts, that part there, this part here is okay. These ones are all aligned, nothing wrong there. That one's aligned, no solder bridges and no tombstone parts. So that's fine. And come back across to the left and come across on the lower level. So if you just look randomly around the board, it's very easy to miss things. So you need to be methodical and actually it's like a grid search. So that all seems to be okay now, from what I can tell through these out of focus eyepieces. No bridges on that chip. No bridges that matter on those resistor networks. This joint looks a little bit on the strange side. In fact, what I think I might do is... no, I won't. What I was going to do was heat up the ultrasonic bath and put this through while I'm still on the live stream, so you can see the result of how it comes out. But I'm not going to do that yet because I still need to put other connectors and things on, and then I'll just end up with solder paste. No more bridges there. That looks okay. These parts look good. So this is how it should be. I had, because I was kind of being very crude with the stencil, you can see that the amount of solder paste that went on here is perfect. So this end is fine. They've all ended up aligned nicely. No solder bridges. These parts have all got the right amount. No little solder balls, which is another indicator of too much solder paste. But then it's down towards this left end of the board, and it's possibly because of the vertical alignment of the stencil that, and also because I did it multiple times. As you saw, I should have. The idea when you're working with a stencil is to do a nice clean pass, and I didn't do a clean pass the first time, so I ended up kind of just wiping over it a couple of times, and then you can end up squishing more, particularly if the stencil has been lifted and then put back down again, which I did. That's really bad, because what it does is, if you've got paste that's gone onto the board, you lift the stencil off and then you put the stencil back down, the solder paste doesn't neatly come back up through the hole. What it does is it squishes out, and then I wiped across it again, which then adds more solder paste into it. So that's why I've ended up with an excess down around some of these components, and that's what's led to that bridging. Yeah, I'm really not showing you good technique in this demonstration, but I was just wanting to see how this board goes together. Alright, so what else do I need to do? I need to solder on pin headers to go into here, and I need to put the big RJ45 sockets onto here. Now, what do I have? So if I was doing multiple boards of this sort of thing, what I would do is make up a jig. Typically I'd do like a 3D printed jig. In fact, oh, here's one. This happened to be just sitting on the bench. So this is a jig that I use for assembling the headers on the IO RJ45 breakout. You can see there's a spot there where I put a pin header in, and there's a spot there where I put a couple of the box headers on for the little breakout headers. And it means it's got the notches in it, which means the connectors go in the correct way. You can't put them in the wrong way. It holds the pin header in the correct position, and it's got legs over here to support the other side of the PCB. So what I do is I load the connectors into this little soldering jig, put the PCB down on top of it upside down, and that holds it perfectly flat, and all of the headers are perfectly straight and aligned. They're oriented the correct way around, and then I can just solder it. So for boards that I do a few of, I make up a jig, something like that. I haven't done that yet for this, so what I'll need to do is just put the pin headers in here and solder them. Do it kind of one at a time and try to keep everything aligned. Oh, I'm throwing parts on the floor. So just have a look in my little box of things. How many do I need? 1, 2, 3, 4 of those, and a couple there. Yeah, so a couple of pairs. And what's that one? That one's 6. I'll save that. Oh, there's a 3. There's another 3. That saves me cutting. Oh, there's another 3. That's a good. Saves me cutting. I am feeling really zonked today. I'm sure you can tell. My brain is just not functioning well. Alright, there's one pair. Oh, there's a pair that's had solder on it at some point in the past, but I'll get those in. Chop this. That should be what I need. Alright, so my goal now, my short-term goal, is just to get the parts on this board, get it assembled before the end of the live stream, because at least then we've got some progress on a project and we can... Is it going to go in? Yeah, I need to clean up those pins a bit more. Oh no, it went in. And then I'm going to have to follow up with proper testing and things, because I'm not going to get to testing this right now on the live stream. Oh, I'm going to turn my solder extraction fan on. More noise in the background, but I'd rather not eat these fumes too much. Just needs a little bit of straightening. This is how to burn your fingers. Hold the other side of the connector while you're heating it up. Heat goes straight through. That's all right. It's kind of aligned. Bit of blue tack to hold it in place. Come on, flow. Before I go any further, I'll just check get that aligned nicely. There we go. Get it bedded down. I might not even get the big connector soldered on the live stream, and that's kind of a boring thing anyway. Look at all these joints that have to be soldered by hand. This is this is where I wish I had a selective soldering machine. Selective soldering machines are freaky and so cool. It's I think I've talked about them on the live stream in the past. It's like if you've seen a chocolate fountain, they so with a chocolate fountain you have typically multiple tiers. It's like a water fountain, except that there is melted chocolate coming out the top, and it just comes straight out the top and then bubbles over and runs down the sides. A selective soldering machine is kind of like that, except that instead of being molten chocolate, it's molten solder, and which is both scary and awesome. And so the PCB sits above it, and the little fountain of molten solder comes up from underneath. Oh, I put a solder bridge in. And oh, come on. Yeah, it comes up underneath each of the pins, and it applies solder just to one of these connections. And of course you can do wave soldering as well, which is where a machine has a bath of molten solder in it, and they set up a standing wave, which is like you know, like those big artificial waves they have for surfing. They have a thing like a wave pool with a wave that just stays in one place, it doesn't move, and you can get on your surfboard and surf the wave, and you're just staying in the same place because the water is moving underneath you instead of you moving over the water. And yeah, imagine that, except that instead of water, it's molten solder. Very, very cool. No, not very cool, very hot. And then the PCB moves over the top of it, and any exposed joints get passed through the wave of molten solder. So many of when you look at large scale PC, like electronics assembly and manufacturing, so many of the parts of the process are really, really scary. Things that you wouldn't want to get too close to. Often involving machines that move very fast or very high temperatures and those sorts of things. How are we going? Alright, so we've got those top connectors on. So these pin headers that I've just installed, these are for setting the I2C addresses of these. So on previous versions, these were set with, on the large version, they were just hard set. You couldn't change the addresses. And on the smaller ones, it had solder jumpers. But I've changed to using pin headers on them so that you can put, in fact, no, not that. I usually have a few of these sitting in my headers box. So for the first one, we'll leave them all off, which makes it the default address. So that'll be I2C address 0 hex 20. And then I'll put a jumper on address 0 on the next one. So that will make it address 21. And I'll put it on address 1 on this one, which will make it address 22. And then for the last one, I will put it on address 0. And this is where counting in binary comes in handy. Address 0 and address 1. So that will set them to I2C addresses of 0 of hex 20, 21, 22, 23. I think, unless I've screwed that up. Hopefully I got it right. All right, now I need RJ45 sockets. I've got, what have I got? There's a box up there. Yes, that's what I need. I have here a big box of those sockets. There we go. So these need to go on here. Clip in. And that needs to go in there. And clip in. That's it. Alright, then they need to be soldered in place. How are we going for time? We're already at 12 o'clock. Okay, what I'm going to do is I'm not going to go through and solder all of these pins on. I am just going to solder the mechanical mounts because I want to get this in place so that from like a physical point of view, it looks just about finished. Oh, and I need to put the other headers on here as well. So what I'm going to do is just solder the mechanical mounting tabs that are on the ends. And on these, I leave the soldering iron on for quite a long time because what that's connected to is the ground plane of the PCB and also the metal case of that connector, which means these tabs, like what I'm soldering right here, this has huge thermal mass attached to it. So what I do is hold the soldering iron on for a while, and that allows the joint to heat up adequately and for the solder to flow properly into the hole, chase its way down in there and attach to the connector. So it's almost complete, apart from those solder joints and these headers. Okay, so I'll put these headers on and then I think I am going to call it for the live stream. Because I am feeling zonked. Ah, wrong headers. I grabbed the large ones. What I need are 6-way. I need IDC6 sockets. What do I have here? Yes, this is what I need. Those little things. I should have done these before putting the large RJ45 sockets on there. So it is annoying getting into this spot. Wonder if there's anybody still here. I haven't looked at the chat for a while. Tell you what, if I was watching this live stream, I wouldn't be here anymore. I would have run away. Okay. Yow. I did the classic burn myself through the connector thing. It's kind of awkward doing this soldering even here too, because I'm sitting here with my head a fair way back from what I'm doing because I'm trying to keep it out of the way of the overhead camera. If I got in close to see what I was doing, you'd be looking at the back of my head. You can just see the solder smoke wafting off to the right there, sort of up and to the right. That's because my little extraction fan is sitting just out of camera view up to the right. So it's sucking all those fumes across, up away from me, and sending them through a carbon filter. Hopefully reducing the nasties of what I'm breathing. Okay. Apart from a heap of solder connections, as you can see there, that still need to be done, that is what the board is going to look like. Still untested, but I think that's in pretty good shape. And so I still need to do assembly of larger versions as well. All right, it is time to mute your voice devices again, because I'm going to say, Alexa, please turn off the soldering iron.
Okay.
And I've got rubbish everywhere now, so I'm going to have to clean up after the live stream. I'm not going to do it right now. Where are we? I don't know. Here. Okay. Jordan said, still 95 of us. Woo. Andy said, even cooler are the high-end Chinese factory soldering machines that squirt a little jet of solder upwards towards the underneath of the PCB. Yeah, that's what I was talking about with the selective soldering machines. Pancake Legend said, chat is still just an AI simulation to keep you sane. You're doing a good job. Thank you, AI Pancake. Yeah, Peter Lawler, of course, will turn any comment into an excuse to talk about lunch. Yes, Peter, pancakes for lunch. Yeah. Green tack. Yeah, I know. Weird. Smurf poo. Not blue tack, it's green tack. Yeah. Okay, so Aaron said, did I test the multimeter PCB? No, I haven't. No, so I've still got it here. Did the assembly, but I have not connected it and tested it. And yeah, that could have taken up the rest of the live stream, and then I wouldn't have got to doing the assembly on this board. So yeah, today has been an assembly stream. Not the most exciting thing, and zero testing so far. Yeah, I'm just wondering if I should... What I will do is a little bit of homework before the next live stream. I will plug that board in and I'll see if it works. Now, I presume... I have reasonably high faith that it's going to work, because it's an implementation of the circuit that we've already had working on the breadboard previously, and there are only 3 parts in it that matter: a transistor and 2 resistors. So unless I really screwed it up when I was doing the board design, it should work. Saying that sounds so cocky, and that's kind of tempting fate. So Stephen says, assume it works and put it directly into production. Yes. Sion, thanks for coming along. Yeah. Oh, Scott says, just make sure the camera is running. We deserve to see the smoke. Yeah, if smoke comes out. Maybe I'll do a little, like an off-schedule live stream when I do that. Sorry. Trying to get my brain engaged. What do I want to do? Okay, I will... Yeah, when I come time to hooking it up, I'm just going to click go live and do an unscheduled live stream. And I won't bother like doing an advanced notification or scheduling it or anything like that. And so I'll probably have about 3 people watching, but at least then when I power it up and do the initial test, it'll end up on YouTube. So you'll be able to go back and see it if you want to see what the result was. All right. Aaron said, is there a way of getting a populated version of the board? Yeah, absolutely. And thanks for the offer to make a case. That is really cool. So what I'll do is I'll send you sequence of events. I will plug this in and test it, and we've already got firmware that publishes the raw code to MQTT. So it's already in a state where you could plug this into the multimeter and have it reporting the raw data coming out of the multimeter to MQTT. I will load that firmware on it. I will send you one, so I'll follow up off the live stream and get some shipping details. And in fact, Aaron, I think I might already have your shipping details. So I'll send you one. And if anyone else cares about this, the thing is that this is just it's a bit of a silly project. If there is anyone else that has a UT61e multimeter and they care about this and actually want one of these in order to connect their multimeter to Wi-Fi, let me know. It's one of those things where I don't know if anyone else is going to care about this. It was just something that I did for my own entertainment, basically. So if anyone wants one, I can probably make them available for sale. The design is already on GitHub anyway for anyone else that wants to do one. Aaron says, I don't have the multimeter strangely, but happy to make the case. Oh, that's really cool. Oh, Mike says, I have one and an MQTT server running as well. Yeah, maybe there'll be people purchasing UT61Es now. Not very likely. Yes. Dodgy said, I did it because I can. Yes, that's true. All right, now, to make Peter happy, I'm going to go and get some lunch. And I think my brain needs the lunch for functionality. So, yeah, I will do that. And I'm not sure when I'm going to connect this up. I don't know if I'm going to feel up to doing more of this today. I might just put it aside and come back to it on another day. But I will go live when that happens. So, thanks everyone for coming along. Oh, John said you should make your own multimeter. I could do that. I could get the chips, like I could use the same chip that's in the UT61e. We could design our own multimeter. We could have a squirrel meter. But it's a big job. And a lot of it is mechanical. I'm not sure that I'd be up to that part of it. Unless we could find an off-the-shelf multimeter enclosure, like just buy a case and design our own PCB to go in it. That could be kind of interesting and cool. We could make an ESP32 based multimeter. And then we could add extra features to it. Oh, I'm already chasing squirrels. I was just thinking it could be a multimeter that also does things like logic analysis and stuff. But, oh, right. Oh, Andy said, OHMC multimeter project. Yeah. Ah, interesting. Yeah. Well, the EEV blog multimeter was a huge project. That took a long, long time. Peter said, stop, for goodness sake, stop. Okay, it's lunchtime. Lunchtime. All right. I'm going to use this finger and I'm going to hit the end button on my OBS scene switcher and go and get some lunch. So you should too. Thank you for coming along. There is lots more to do, but we can always do it later. There is more time. Thank you. Bye. Come on, OBS.